Okay, so grade 9, the third topic of unit 2 was to understand what exactly is a charge and how can a charge be static or in motion. Okay, if it is static, which means not moving, that is your electrostatic. And if it is moving, then it becomes your current. So let us understand now what is charge. If you remember in the class demo done in class was using a balloon, right? So what did we do using a balloon? We took a balloon and then we had a person whose hairs we used, and then we rubbed here. So when you rubbed, you actually caused an effect of friction, and because of friction, one object lost negative charge and the other gained. Okay, hence that is why the object which lost the negative charge became positive, and the object which gained the negative charge became negative. So technically if you see any object in nature, okay, so any object in nature is neutral, which means the number of negative charge will always be equal to number of positive charge. But because you caused a friction, because of your friction, you were able to separate them. You were able to take out some of the negative charge from one of the surface and transfer it to the other surface, right? So this way you can create charge. So basically if you see, charge is nothing but it's a nature of a substance in terms of negative or positive. Okay, that's how it works actually. Now we did some more demo also. So we got the balloon, and we had the tap here. Okay, we had the tap. So the tap was here, this was a tap, and then the water was falling down, but the water which was falling down was bending. See, the water which was falling down was bending. The question was, why does the water bend? Why did the flowing water bend, right? So if this is, for example, say positive charge, this is positively charged, then what will happen is it will pull all the negative charges from the water this side, and due to this attraction, the water bends, right? And the same thing, when we repeated the same thing with the Van de Graaff generator, Van de Graaff generator, we saw the hairs standing up and spreading. So in the Van de Graaff generator, if you recall, in the Van de Graaff generator you had a wheel, and then on this wheel you had a cover here. So you also had a sort of cover here like this, round, and then there was a belt here, like this, right? And then the belt was fixed here on a box. It was a box here, so it was an electrical box. So there was a switch here, all those things were there. Switch, positive, negative. So when the wheel was rotating, the hairs, where were the hairs? If you recall, the hairs were here, but then they were all spreading up like this, right? So they were spreading out. The hairs were spreading out. What did this mean now? What did this show actually? It showed that all the hairs had same type of charge. So for example, if the belt is taking all the positive charges, and then all these positive charges are now getting deposited here, right? Then all these hairs are also having positive charges. So all the hairs had same type of charge and they were repelling. Right? So what do we mean by repelling now here? See, so this means that like charges always repel. By like charges I mean similar charges. And unlike charges always attract. Right? Unlike charges means dissimilar. So this was the basic idea that we just observed, and we understood that what exactly is a charge, because this is a very important term for us. Okay, this is a very important term for us. So now we know what certain things. One of them is that there are two types of charges, and we know that they can either attract by unlike, or they can repel between like charges. Okay, so this concept that we saw with various examples, that was meant for a electrostatic. So all these cases are where the charges were not in motion. They remained on the surface. Of object. But what if they can move? When do they move? See, all these are very important questions. Will they move in a rubber? Will they move inside a plastic or a rubber? Plastic. Why? That's a question. So, which clearly indicates that there are two types of there are two types of there are two types of material known as conductors and insulators. Okay, and conductors allow charges to flow through them, right, through them, while insulators don't allow the charges to flow. Now this concept, the motion of charge, when the charge actually moves, right, when the charge actually moves, is known as your current, okay, and current is then defined as amount of charge flowing per unit time in a conductor. So current is written as I equal to Q by T, where Q is the charge and T is the time, and charge is measured in terms of Coulomb or capital C, which means I unit is Coulomb per second, which means it is Coulomb per second. This together total is also represented as ampere or capital A. So for current we will use ampere as the unit, okay, and for charge we will use Coulomb as the unit. Okay, so I think we will end here and then we'll continue in the next class. So do some research here, okay, do some research here. What exactly is this word? Do some research and come next class. So come for next class, we will discuss this further, okay, we will discuss further. So that should be fine. Further.